Okay, so let's answer some questions on surface tracing. So generally, if you are given something like this, basically if it's you have to do the following. So you have to see if it's symmetrical um, according to six um, parts. So with respect to the y-axis, the x-axis, the z-axis, as well as the three planes, xy, xz, and yz. So we'll be writing that down later completely. So after symmetry, what you have to worry about is the intercepts. You have to identify the x, y, and z intercepts. And for the third, you have to draw um, the traces. And then number 4, you have to draw the sections. And then for the last step, you basically have to sketch the graph. Given according to what you've drawn in your sections and traces. And you get these because you got the intercepts. And yeah, basically this is the order that you follow. So let's check symmetry first. So with respect to the y-axis, sorry, the x-axis, basically what I wrote here were the variables that were not mentioned. So if I mention x here as the axis, what remains is what remains are y and z, right? So that's what I write there. And then yeah, just substitute. So y becomes negative y. If we substitute, does that change the equation? It doesn't change the equation. We see that z becomes negative z, but we don't see the variable z in this equation. So we just ignore this, but we still write it anyways. And yeah, the equation is still the same as this, the given. So symmetrical with respect to the x-axis. That's what we could conclude. Next, with respect to the y-axis, so x becomes negative x, and then what's also not mentioned is z, right? So when we substitute, negative x times negative x is still x, right? So yeah, it is symmetrical with respect to the y-axis. How about with respect to the x-axis? So y becomes negative y, z becomes negative z. X squared plus, okay. Yeah, symmetrical with respect to the x-axis also. I think this is a circle. It copies the form x minus h raised to 2 plus y minus k raised to 2 is equal to the radius. It makes more sense because 4, r could be 2 if r squared is 4, right? If you think about it. Okay, next, with respect to the xy plane, so we're going to make z negative z. Does that change anything in the equation? We don't see z in the equation, so we just literally copy the equation. And we say that it is symmetrical with respect to the xy plane. How about with respect to the xz plane? So y is going to be negative y. It follows a pattern. The equation does not change. So we say that it is symmetrical with respect to the xz plane. How about the yz plane, the last of the three planes? We're gonna make x negative x. So x squared plus y squared equal to 4. Nothing changes. It is symmetrical to all of these with respect to all of those. So we are now done with symmetry. We just put a label, proper label. Now let's move to intercepts. Number 2. So let's start with the x-intercept. We're going to make y equal to z equal to 0, right? So, uh, so y is going to be 0. We don't see z, so we don't mind that. The equation is going to be x squared plus 0 squared equal to 4, or just 0, no? So x is going to be plus minus 2. If you put a radical sign, don't forget to put this symbol. Okay, so 2, 0, 0, and negative 2, 0, 0. Usually, when I'm going to tell this to you now, this is the only point that we're going to care about. Because generally, this is the illustration. Our order, the order that we will follow is that x is here, y is here, and z is here. So in this case, at the bottom we have negative z, here we have negative x, and here we have negative y. We are not going to mind whatever, because in this point, the negative 2, 0, 0, it's basically found where? Here, right? So let's assume this is negative 2, 0, and 0. Like this distance is negative 2. We don't actually mind that when we illustrate the traces as well as the sections for later. And on the using 200, it's basically found here, right? And if ever we find other intercepts, let's say here, we can draw something like that. But more on that later. What I've drawn isn't for this example, it's just to show you what it's supposed to look like later, usually. So x-intercept, we're done. Y-intercept, let x equal to z equal to 0. X is going to be 0. And then y squared equal to 4. Y is equal to plus minus 2. Okay. So 0, 2, 0, and 0, negative 2, 0. Those are the y-intercepts. How about the z-intercepts? Let x equal to y equal to 0. So again, x squared is going to be 0, and then plus 0 equal to 4. So if you see something like this, like the left side isn't equal to the right side, it tells you that this intercept does not exist. Or basically there is no z-intercept in our scenario right now. So those are the intercepts. Let's now move on to the traces. Okay, so for traces, we are going to have a trace for each plane. We have 3 planes in total. So we start first with the xy plane. For the xy plane, what do we put here? So xyz, right? Whatever is not mentioned here, so xy. What's not mentioned is z. We are going to assume z as 0. That's always going to be the standard. What's next? Kind of forgot already. Okay, so we go back to what you are given, the equation. Z is 0. You substitute z in the equation, but you see that there is no z. So what do? We just copy. So we just copy the equation. And you can, you're supposed to explain that yeah. So this is a circle, right? Circle is Because in the previous examples that I've studied, we deal with lines, not circles. This is a new example to me. Mm, let's identify the center. Um, so given the intercepts, I think we can say that since one thing in common is that the distance is usually 2, right? If you visualize, the radius could be 2 and the center is the origin. So 0, 0, 0. And the radius is equal to 2. And yes, we'll say that the circle is lying on the plane z is equal to 0. I'm just following the pattern that was taught to us. If this were a line, we could say that the line is parallel to the YZ. Wait. Actually, what we're doing is right so far. Forget about what I said. We're supposed to do that when we arrive in sections. Just for now, we put this. Actually, let me try saving this for x, y, z. Save. Okay. Okay, so this is the origin. This is R, this is R, this is R. But we're only focusing on the xy plane. So this plane. This is what? 0, 2, 0. This one is the 2, 0, 0. Those were the intercepts that we found earlier, right? 2, 0, 0 and 0, 2, 0. Yeah, the only intercepts that matter, actually. So this is a circle, right? So we draw a curve. It's definitely not a line. So yeah, that is for the xy plane. We need as much space as possible. Xc plane. We are going to assume that y is equal to 0. xyz, what's mentioned here is xz. So you put here the missing letter, y. And, okay, so y is equal to 0, right? Substitute in the original equation. We get x squared equal to 4. Y squared, 0 squared is just 0. So what we're left with, I think, yeah, this is definitely a line. Now let's Let's reuse the same. Okay, so how do we show the x equal to 2? Obviously, we're not going to show x is equal to -2 anymore. That's not part like what I said earlier, because it's somewhere here. We don't show that anymore. What plane is this? XZ, right? Yeah, so makes sense that we don't, yeah, we don't mind this region anymore. X is equal to 2. This is this is 2. We just draw a line. And you can say that this line is parallel to the z-axis. Yeah. Okay. That is for the xz plane. For the yz plane, x is equal to 0. So like y squared is equal to 4. This is what we end up with. Okay. The lines are parallel to what? Actually, another way of knowing which axis this line is parallel to is by looking here. Let me show that here. So we know that in the xz plane, x equal to plus minus 2 in general is parallel to the z-axis, right? We showed it graphically. But even without a graph, you can know that it's parallel to the z-axis by looking at the variable that's not mentioned. What I mean by that is, we've been dealing with x, right? So the other variable is always going to be, basically you connected with the word axis, and that's what it's parallel to. That's my thinking process. So in that, using the same logic, we've been dealing with y, right? So whatever is not y, that is z. So we write z-axis. And to prove that, we'll show it graphically also. There's just not much space. Let me show it here. So xz plane, x is equal to 0. Y is equal to 2. This is where we put the line. And as you can see, the line is parallel to the z-axis. So yeah, it's a lot of graphing. The concept is fairly easy. You just have to make sure that you are graphing the right graphs. Next, after traces, we draw the sections. There is a section again for each plane. So xy section. So previously for traces, xyz, what's not mentioned here is z. we used to equate it to 0, right? In sections, we equate it to k. K means constant. And from there, we get again from the original equation. I'll just copy it here. We try to substitute, but in this case, there is nothing to substitute since z is not seen in the equation. So we just write as is. We know that this is a circle. We'll reiterate that the center is 0, 0. But since z is k, we put k. That's the difference. Okay? Here, everything was 0, right? Since z was 0. But this time, since z is equal to k, this is the new center. And how do we describe the circle? It is lying on the plane z is equal to k. We just copy this. Now we graph. Okay. How do we graph this? So we said that z is equal to k, right? Let's label again. This is y, this is, this is x, this is y, this is z. Z is equal to k. We put k somewhere here. And yeah, I almost forgot to mention, this is very important. Now that you've drawn the traces, 3 of them, for each graph in the section, it has to contain those. So this is from the first trace, this one, and then the second trace, and then the third are just vertical lines. So yeah, something like that. So right now, the constant is over here, right? When we draw dashed lines, it has to be parallel to whatever axis it may be close to. So right now, we can show that it's parallel to the y-axis, so we do that. We can show in the other side that it is parallel to the x-axis, so we show that. Oops. There you go. And then, actually, we don't need them anymore. So, yeah. And then, do that. Let me verify if I'm following the right steps. Let's try The next section, xz, y is equal to k. So how do we apply that in the original equation? X squared plus y is going to be k, right? So k raised to 2 equal to 4. We manipulate the equation such that we move k to the left side, sorry, to the right side. So 4 minus k squared. By the looks of it, all of these are constants. So, and then this one is an x squared. I think this is a parabola. What's the vertex? Wait. So 4 minus x squared plus minus k. Okay, in the xz plane earlier, lines are parallel to the z-axis. And yeah, lying on the plane y is equal to k. Okay, again we draw the traces. Y is equal to k, right? So again label x, y, z. Y is over here, we put k over here. We can show that it's parallel. So we have something like this. By the way, if you see that the figure looks closed, for example here, the figure was closed. Basically these red lines were able to cut these two lines. That means this is what you will draw in your final sketch. Because basically it demonstrates that you were able to sketch what figure is this? You were able to sketch this figure on the first octant. YZ section x is equal to k. X, okay, k raised to 2 plus y squared equal to 4. Do the same thing. Transpose k to the right side. Lines are also parallel to the z-axis, coming from what we found out earlier. And it is lying on the plane, what plane? X equal to k. Okay. We draw the basics again. The bare minimum. Traces. X is equal to k. X is over here. So this is k. parallel to the z-axis, parallel also to the y-axis. Wait a minute. I think this figure is supposed to, basically the red lines are supposed to be like this. So like essentially, when we do the sketching again, uh, you put this, 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 and you just copy this. Cylinder. Yeah, I can confirm that it is a cylinder actually. Ah, I mentioned that it was a circle in the context of 2D, but in 3D, it would look like a cylinder. That makes sense. Yeah, our illustration is very similar. Let me show you. So, yeah, this is what the figure looks like. And don't forget to show what region to shade. How do we do that? So it's between um, this and this. They essentially have the same equation, only they have a different uh, center, I think, or vertex. Let's find. Okay, so this is x raised to 2 plus y raised to 2 equal to 4. That is if the center is 0, 0, 0. But if the center were to be this is what we get. But essentially the equation is the same. So like, yeah, it's not this region, that would be wrong. Your thought process is supposed to be, it's between these two curves. So yeah, that's it for the first question. Number 2 is z equal to y. Wait, didn't I answer this earlier? Yeah, I already answered this a while ago. Just y is equal to z. Not sure if that's gonna make any difference. I mean, you just change the order, right? Let's do it anyways. So symmetry. So if you rewrite the equation like this, the negatives will cancel. So it's still the same equation, so you say that it is symmetrical. So you're right, yes. With respect to the x-axis, negative z is equal to y. No, not symmetrical. The equation is no longer the same. Is my mic open? Okay, good. I thought I was speaking to a ghost the entire time. Nope. With respect to the xy plane, xy plane is z becomes negative z. Nope, not symmetrical. Since there's no x in the equation, you just copy the equation itself and you say that it is symmetrical. Okay, we're done with symmetry. Next, intercepts. Okay. I don't like how this z is written. Let me rewrite that. Z is equal to 0. And then y. Oh, y is equal to 0 also. What's this supposed to mean? So if you end up with something like this, Um, Although yes, it's true that 0 is equal to 0. When you see something like this specifically, it means that this intercept does not exist, or there is none. There is no x-intercept. That's what it thinks, but later, there actually is. We'll show that later. For the y-intercept, let x equal to z equal to 0. So 0 is equal to y. Okay, so 0, 0, 0. I think it's just the origin all the way. We'll see. Z-intercept, let x is equal to y equal to 0. Z is equal to 0. Yeah, it leads to the same thing. We have a point at the origin, or an intercept. Okay, now let's move on to traces. The first plane, xy plane, sorry. We draw the trace for the xy plane. Let xyz, z is not there, so z equate to 0. And then we have to go back to the original equation, which is z is equal to y, and then equate. So y is going to be equal to 0. So this is going to be 0. That's how I got this. So let's see how this is supposed to look like in a graph. This is y, x, z. No, sorry, this is supposed to be y, this is supposed to be x. Y equal to 0 is this. This is only in the xy plane, okay? If we're talking about in general, like in the actual 3D space, y is also 0 here, but we're not talking about the z-axis right now. We're only focusing on the xy plane, this plane. So yeah, this is the xy trace already. We've shown it. Next, xz trace, xyz, y is not mentioned here, so y equal to 0. Going back to the original equation, if y is equal to 0, z is equal to 0. How do we show that? So again, this is x, this is y, this is z. Xz plane, so we're only looking at this plane. X being equal to 0, I think it's also this. Yeah. So this is the xz trace. Finally, let's draw the yz trace. So xyz, x is missing, x equate to 0. Is there x in this equation, the original? None. So we just write z equal to y. Or in other words, just copy paste the equation. Then draw that. How do we show that z is equal to y? Again, let's label x, y, z. So essentially, in this kind of scenario, there is a 45-degree line on the yz plane. This is gonna be your yz trace. it is lying on the YZ plane. In other words, lying on the x equal to 0 plane. The XY plane is, in other words, called the Z is equal to 0 plane. So, yeah, you need some time to absorb all that. We're done with the traces. Let's now draw the sections. XY section, XYZ, Z is missing, equates Z to the constant K. And then, go back to the original equation. What do we have again? Z is equal to K, right? So equate Z, basically substitute Z as K, Y is equal to K. What line is this? You know that it's a line since there's no squared. Yeah, it's self-explanatory. Whoops. Okay, so how do you describe the line? We've been talking about y, right? Line is parallel to what axis? We've been talking about y. What's the letter that's not mentioned? X, right? So we write x axis. And it is lying on the plane this. So just copy. Z equal to K. There you go. And then, how do you graph that? Y is equal to K. So K is somewhere here. Actually, no, wait. Sorry. My bad. You're supposed to look here. Z is equal to K. So in the Z axis, K is located probably somewhere here. So again, make dashed lines that show that it's parallel to the axis that it's close to. Right now, it could be parallel to the y-axis, so you show that. It could also be parallel to the x-axis, so you also show that. So that's what the graph looks like. Oh yeah, I almost forgot. Coming from the traces that we drew a while ago, every section has to have that. So automatically, we have this. So what do we do now? Actually, we don't. Okay, so from there, how do we draw the XY section? Let me just verify again. I'm not sure with my own drawing. The one I drew earlier. Ah. Okay, so essentially it has to be parallel to this. No, not that. This one. Y equal to 0, Z equal to 0, and Z equal to Y. So yeah, it's just that. Okay, now let's draw the XZ section. Y is equal to K. So Z is equal to K. This is a line parallel to what axis? We've been talking about z, right? So the variable not mentioned is x, so we put x-axis. And it is lying on the plane, just copy, y is equal to k. Again, by default, you draw this. Y is equal to k. This is x, this is y, this is z. Y is over here. Okay, so we can form a dashed line like that, and parallel to the x-axis. The xz section will be drawn like this. Okay. Now let's draw the YZ section. X is equal to k. There's no x in the equation, so we just copy paste. Z is equal to y. This is a line parallel to z, right? So what's not mentioned is y axis, and it is lying. Wait a minute, wait. Y is mentioned here also, so this is how we define it. So line YZ is lying on the plane x equal to k. That's it. There's no report of anything that's parallel in this case. And right now, again, this is a section, so whatever you found in the traces, you write it here. Your k is over here. So yeah, how can you show that the dashed lines from k are parallel? You show it this way. This is the only way, actually. And the line is going to be parallel this way. So this is the YZ section. Okay, now let's draw the sketch. Again, the traces, this is what we found out. And sorry. I need to tell you this. This is a minor correction. In the traces, the YZ trace connecting to the other traces here, it's not a straight diagonal line. This one's a little inclined to the right. So the effect that is being delivered is that this one's a little slightly right. How do I show that properly? Okay. It has to show that it's parallel to this line, which is also parallel to this. How about for the second section, XZ? Let's fix this. There you go. Okay, and then there you go. Okay, so that is the XZ section. And then here, the last section, so yeah, you want this to be parallel to this. That's the goal. Okay, going back. It was a good thing that that correction was made, because it could be a lot more confusing if I didn't bring that up. Okay, and then we have to choose among the sections which section was able to show actually I think there's no single section that was able to show what we have to show for the sketch. I believe it's a combination. Yeah, it is a combination. Which sections, to be specific? X, Y, and YZ. We're not going to use this, but we still show it to merit complete points as much as possible. Okay, XY section, XZ section, sorry, YZ section, oh wait, no, it's not that gradual. This has to be parallel to this. It's not parallel enough. So let's just say this is a crude sketch of what we're trying to show. And this is the area that we shade. Label. This is the YZ section. The other one is the XY section. Okay, that would be it. These are 10 questions. We only answered 2. This is gonna be long if I try to finish everything. But I think I was able to show the idea. The only limitation is that I'm not able to cover everything because every example can be a different scenario. Okay, that's it. Adios.